Okay, hey everybody. What we are doing tonight is we are doing some more work on what we started in class today about solving word problems that are going to ask us to create algebraic expressions and then solve the equation that goes along with them. And so what we're going to start with is a quick do now. Okay. We are going to write an expression, an algebraic expression that describes each of the following situations. What might be helpful this time is to try number one right now. Pause the video, try number one, see if you get it by unpausing the video, and then based on comparing your answer to my answer, you can then pause the video again, try number 2 and 3 on your own, and then check your answer with what I am going to say. So right now, go ahead and pause, try number one, and then come back. Okay, welcome back. An online ticketing service like Ticketmaster charges a convenience fee of $3 to use their service. I'm going to underline that right there. Convenience fee of $3 and $27 per ticket. And then I am going to highlight my keyword plus, okay? And so we can figure out what they charge for an order by this expression. A convenience fee of $3, that does not change, plus $27 for each ticket. So I need a variable, and it seems like T would probably be a good one for ticket. So the way I would figure out what the cost of the order is $3 plus $27 times the number of tickets, or 27T. Okay, so go ahead and pause, try number 2 and 3, and then we will go over them in just a minute. Okay, so for number 2, a 5-year-old is given a $1 allowance plus 50 cents for each chore he does each week. Okay, so I'm going to underline my important information. $1 allowance, that kind of seems to me to imply that he's going to get it no matter what, and it's not going to change. And then 50 cents for each chore. Okay, again, the plus tells us we're going to be adding. So I have $1 he's making no matter what, plus 50 cents, $1 plus 0.50 plus 50 cents for each chore. So that means times the number of chores. I'm going to pick C to represent the number of chores. So we have $1 plus 50 cents times C. Okay, and that will, once we know what C is, we can plug it in here and know what this child is going to make for the week. Okay, and finally, number 3. Mr. Duncan has 4 complete boxes of colored pencils plus 3 loose pencils. How many does he have? Well, it's not telling us how many markers are in, or colored pencils are in each box, but what it does tell us is that we have 4 complete boxes. So I'm going to say 4B, and once I figure out how many are in each box, I can plug that in for B. So 4 times the number in each box plus 3 will give me an expression that will describe how many colored pencils I have. If we later found out that B is 12, then it's 4 times 12 plus 3, and we figure out that it's 51. Okay, so that is what we are doing. We are translating things into algebra, and then in the lesson today, we are going to create equations to go with them. Okay, so we're moving on. I believe we've done this in class. Happy Paws charges a flat fee of $19 plus $1.50 per hour to dog sit for the day. Okay, so they're going to be watching our dog. So Happy Paws, let's create an expression to describe what they are doing here. $19 just because that's what it costs to start. $19 does not change, so no variable with it, plus $1.50 per hour. So $1.50 times my number of hours, or 150 each. So Happy Paws, the expression will be $19 plus 150 times each. Okay. Now I'm going to read my next sentence. A rival service, Wolf Watchers, so WW, is going to charge a flat fee of $15 plus $2.75 per hour. So notice it starts off a little cheaper for the flat fee, but the hourly fee is going to be more. So we write that $15, that's our flat fee, no variable with that, plus $2.75 for each hour, so times H. Okay, so now we have two expressions, one for Happy Paws, one for Wolf Watchers, and we know how to describe how much each of them charge. Now here's where this becomes useful, because what we're going to do is look at our next sentence now. It says find the number of hours for which you would pay the same. And I'm going to circle that word right there, because same in math tells us to do a very, very special thing. Find the number of hours for which you would pay the same total fee to both services. That should be an S there, services. Okay? The word same that we just circled means equal. Okay? For which number of hours would these two services charge us the same thing? And what we're going to do is we're just going to do this. We're going to take the expression we've already made. We're going to bring it down here. For which number of hours is Happy Paws equal to Wolf Watchers? Okay. So for what value of H are these two expressions the same? That's what that's asking. So I have my one expression from Happy Paws. That's going to be right here. Okay. That's this one here. Okay. And then my expression for Wolf Watchers right here. I set them equal to each other because that means they're the same, and now I just have to solve for H. That will tell me how many hours it is that makes them the same. Well, first thing I notice, though, is that I have variables on both sides. I know I don't like that, so what I'm going to do is I'm going to take the smaller one away, minus 150H, minus 150H, okay? And I get $19 is equal to $15 plus, well, what's 275 minus 150? 125H. Okay? So that's what this boils down to. And then we just have a simple two-step equation where I'm going to do the same thing to both sides until I have H by itself. So I subtract 15 from both sides. Okay. 15 minus 15 is 0. 19 minus 15 is 4. So I have $4 is equal to $1.25 H. And then to get H by itself finally, I will divide both sides by $1.25. These will cross out and leave me just H. This I would divide by $1.25. And when I do 4 divided by 1.25, on a calculator you can verify it, you get H is equal to 3.2, and that is your number of hours that would make both of these services charge the same. So if you brought your dog in for 3.2 hours, you would pay the same thing no matter which service you went to. If you brought it in for 3 hours, which is less, you would pay less with one or the other. And then if you brought it in for 4 hours, which is more, it would become the other service that was more expensive. Okay? But 3.2 hours is the balancing point where they both charge the same thing. We're going to do another couple of examples. Al's Rentals charges $25 an hour to rent a sailboard and a wetsuit. So Al's Rentals is just charging us $25 an hour, so $25 times H, and that gives us both the sailboard and the wetsuit that we want. Then we talk about the other one. Wendy's Rentals charges $20 per hour plus $15 extra for a wetsuit. So for Wendy's Rentals, she's going to charge us $20 per hour, so $20 times H. So it's cheaper, but she's plus the $15 that she just charged us once for renting a wetsuit, no matter how long we have it. And then it says find the number of hours for which the two companies charge the same amount. So this is pretty straightforward. Once again, what I'm going to do is I'm going to say, when are these two the same? When does 25H equal 20H plus 15? Okay, and now all I have to do is solve this to find my number of, to find H, which is my number of hours. Okay, so minus 20H minus 20H. I have 5H is equal to 15. And now all I'm going to do is divide by $5 on each side. Divide by $5. $15 divided by $5 is going to equal H. So I get that H is equal to 3. So for 3 hours, both of these companies would charge me the same thing for renting things, both the sailboard and the wetsuit. But anything that's not 3 hours, they would be charging different amounts. Okay, got it? Good, let's try one more. Mr. Duncan runs the same distance every day. On Mondays, Fridays, and Saturdays. Well, first of all, same distance every day. Remember that word same means equal. Okay, so that's important information right there. I run the same distance every day. This is not true, but if this were true, then we'd be able to answer this question. Okay, Mondays, Fridays, and Saturdays, he runs 3 laps on a running trail, and that means plus runs 5 more miles. On Tuesdays and Thursdays, or I'm sorry, Tuesdays and Thursdays, he runs 4 laps on the running trail, and that means plus, then runs 2.5 more miles. Finally, on Wednesdays, he only runs laps. How many laps does he run on Wednesdays? Well, let's start with the first. There's a lot of stuff going on here. But what we're going to start with is knowing that Mr. Duncan runs the same distance every day, which means I'm going to have an equal sign right in the middle. And then I'm going to come up with a couple of expressions. For Mondays, Fridays, and Saturdays, it says that Mr. Duncan runs 3 laps, so 3 times, how about L for lap, and plus 5 miles. Okay? 3L plus 5 miles. And then on Tuesdays and Thursdays, he runs 4 laps, 4L, plus 2.5 miles. So 4 laps plus 2.5. I have no idea how long a lap is. That's my variable. I do know how long a mile is, so that's not a variable. But I have 3L plus 5. Has to be the same because I run the same distance every day, as it says right here. Okay? The same distance every day, which means one expression here, which was from, what was that? Tuesdays and Thursdays, has to be the same as Mondays, Fridays, and Saturdays, which is 3 laps plus 5 more miles. So let me just label this real quick. This was Tuesdays and Thursdays. Okay. Tuesdays and Thursdays, I run 4L plus 2.5. Mondays, Fridays, Saturdays, 3L plus 5. And then what we're going to do is we're going to solve this. And once again, I notice, well, something I don't like. I've got a variable here. I've got a variable here on the other side. I need to fix that. So let me just get rid of the smaller one, which is 3L. Subtract 3L from this side. Subtract 3L from this side. Rewrite my equation. I get that 5 is equal to L plus 2.5. Great. However, I'm not done. I don't have L by itself. the way I get L by itself is just subtract 2.5. Subtract 2.5. 5 minus 2.5 is 2.5. So 2.5 equals L. Here's where I need everyone to be very careful. This is not our answer. Let's go back to the question. It says, on Wednesdays I run only laps. How many laps do I run? Okay. I have no idea. All I know is how long a lap is, which is 2.5 miles. In order to figure out how many laps I run on Wednesdays, I need to use my information again that on Mondays, Fridays, and Saturdays, I run 3 laps plus 5 miles. So let's figure out how many laps I run on any of these days, because I run the same amount every day. So if on Mondays, Wednesdays, Fridays, I run 3L plus 5. Then let's figure out how much that actually is, because I know what L is now. So this is, L is 2.5. So I am going to say 3 times 2.5 plus 5. Well, 3 times 2.5 is 7.5 plus 5. My goodness, I run a lot of miles, don't I? 7.5 plus 5 is going to give me 12.5 miles. This is how much I run on a single day. We use Monday, Wednesday, Friday, but remember I run the same every day. And I know that L is 2.5. Now what I need to do is figure out the actual question. How many laps on, which day was it that I only run laps? It was Wednesdays. How many laps on Wednesdays? Okay. Okay. So what I need to do is I know that on Wednesdays I'm running the same as every day, which is 12.5 miles. But I know I'm doing it around a track that is 2.5 miles long. So 12.5 divided by 2.5, I need to figure out how many that is, and that is going to equal 5 laps. You can verify that on a calculator. That is the way you do that. That is a somewhat complicated question, but if you just start piecing together the information that you're given up here, figure out what your variable is, how long a lap is, and then read the question again, you'll be able to answer this question. Okay? Okay, and one final question. I believe that is the last question. Yes, it is. So one final question. Miss Scott is trying to arrange her class desks for a test. She first tries to fill up 3 rows, but finds that she has too many, 14, chairs left over. So when she uses 3 rows, she has 14 chairs left over. Okay? So the way that we will express this is the number of chairs she has is equal to 3 times R, however many are in a row. Okay? So 3 times R, and how many does she have left after that? 14. She's got 14 left, so 3R plus 14 will equal all of her chairs. She finds that she has too many doing that, though. So then she tries to fill up 5 rows. So if she fills up 5 rows in her classroom, then she has only 2 chairs left. Okay? So we say that 5 rows, however many a row is, 5 rows plus 2 is going to give her the same amount. So what we say is that 3R plus 14 equals 5R plus 2, because she's got the same number of chairs that she's trying to fit in her classroom. And then the question is, how many chairs is she trying to arrange? I want you to be very careful, because once we solve for R, we are not done. Okay? And you can pause for a second and think about why that would be. We do have to solve for R, but remember, R is number of chairs in a row, not the number of chairs total. Okay? So let's go ahead and solve this real quick. We subtract 3R from both sides. We get 14 is equal to 2R plus 2. We then try to get r by itself, so first we subtract 2 from both sides. We get 12 is equal to 2r. Finally, we divide by 2 to get r by itself. We get that 6 is equal to r. Okay? So I know that there are 6 chairs in a row. This is not how many she's trying to arrange, though. To figure out how many she actually has, well, let's use one of the pieces of information we have from the beginning. That the chair she has is either 3 rows plus 14 or 5 rows plus 2. It doesn't matter which one we use because they are equal expressions. So let's go ahead and use this one. The numbers look prettier. 5r plus 2. Okay? 5r plus 2 is one way that she tried to arrange her chairs. 5r plus 2, I know that has to equal her number of chairs. And what I'm going to do is, I know what r is now. 5 times 6 plus 2 is going to be number of chairs. Well, 5 times 6 is 30 plus 2, so I know that she has 32 chairs. You have to be very careful to read the question, make sure you are answering the correct question, and do not believe that once you find the value of a variable, like we did right here, just because we find a variable doesn't mean we're done. You have to go back to the question, reread it, make sure you've actually answered the question, and that your question makes sense. If you tried to tell me that there are 6 chairs total, instead of just 6 chairs in a row, then this would not make sense over here. She had 5 rows in her classroom and had 2 chairs left over. That doesn't make any sense because 5 chairs plus 2 left over, she's got at least 7 chairs. You can't say she had 6. Okay, so you need to make sure that your answer makes sense when you're done. I invite you to do the last questions by yourself, and good luck.